Okay, so in this video, we're going to take a look at how to find the equation of a perpendicular bisector. Now, before we even start, let's just make sure we know what a perpendicular bisector is. So let's imagine we have 2 points, A and B. So they could be connected by a line segment like that. So that's the line AB. Now, the perpendicular bisector of that line is a line that crosses it right at its midpoint. So let's imagine M is there. Look, that's the midpoint of the line A and B. And perpendicular means at 90 degrees, at right angles, right? So what we're going to use is we're going to use some of our techniques we know from parallel and perpendicular lines to help us find the gradient of a line that is perpendicular to that. So this line, okay, is the perpendicular bisector of AB. Okay, so with that in mind, let's see if we can do an example question and work this through in little stages to figure out how to do this. Okay, so we've got this line AB, and A has a coordinate 4, 8, and B has a coordinate 0, 2. So if I was going to draw this, let's imagine we've got some axes. Okay, here's my x-axis, here's my y-axis. B would be on the y-axis, right? Okay, so there's B, look, that's 0, 2. And the point A is 4 across and 8 up. This isn't to scale or anything, but let's imagine A is there, look, there's 4, 8. Okay, so if I join those up, we can see that line. And so the line that we're looking for is going to look something like this, okay? Something like this, which passes at 90 degrees. Right, so first of all, let's just think about our perpendicular bisector. It's a straight line. Well, if it's a straight line, that means it's going to have the equation y equals mx plus c. So the next thing to think about is, well, how could we find the gradient, the m value? Well, there is a relationship between perpendicular lines and gradients. Let's start off by finding the gradient of AB. So that is going to be the change in y between the 2 points divided by the change in x, the rise over run. Well, if we look at those y coordinates, from 2 to 8 is a change of 6. So change in y is 6, and from 0 to 4 is a change of 4. So our gradient of AB is going to be 6 divided by 4. Well, let's write it as 3 over 2. Now, the gradient of the perpendicular bisector is going to be related to this. If you remember, it's the negative reciprocal of this gradient. So if I wanted the gradient of, all right, PB for the perpendicular bisector, that is going to be the negative reciprocal, which is negative 2/3. So my equation becomes y equals negative 2/3 x plus c. So we're not finished because we haven't found the c value yet, but we are in good shape. We've got part of our equation done. Now, in order to find the c, we need a coordinate point on that perpendicular bisector. So what we need to do is we need to find the value, let's call it m again, the value of m, that coordinate point. Well, if m is the midpoint of A to B, it's going to have the middle of the 2 y values and the middle of the 2 x values. So there is a formula for this, and we add them together and divide by 2. So if I wanted to work out the x coordinate, I would do 0 plus 4 divided by 2. And the y coordinate would be 2 plus 8 divided by 2. This is going to give us that coordinate point of m. So its x coordinate would be 2, and its y coordinate would be 5. There we go. Now, the reason for doing this is because now we have enough information to substitute into that equation we found. We could put y is equal to 5, while x is equal to 2 in there, and that might help us to find out what that value of c is. So let's do that. So if I sub in y is 5, we know it's 5 when x is 2. So 5 is equal to minus 2 over 3 multiplied by 2 plus c. So let's solve this equation to see if we can find c. We're going to have 5 is equal to negative 4 over 3 plus c. So let's add 4 over 3 to both sides. So that's going to be 5 plus a 4 over 3 is equal to our c. Well, 4 over 3 is the same thing as 1 and a third, but perhaps it's easier to write the 15 in terms of thirds as well. So maybe I should write 15 as, 5 as 15 over 3. So I could write it like that. So my c is going to be 19 over 3. Now then, let's put that into that equation that we found, 19 over 3. So my final answer, or perhaps we'll write this in green, is y is equal to minus 2 over 3x plus 19 over 3. There we go. So that's the equation of our perpendicular bisector. Now, we again might want to tidy this up and write this in a better format without the fractions. So if I multiply both sides by 3, I'd have 3y equal to minus 2x plus 19. I could then add 2x to both sides and say that 2x plus 3y equals 19. I like this format too. This is a nicer way perhaps of writing the equation of that perpendicular bisector. Okay, so in summary, what we are doing is we are going to find the gradient of the two original points. We're then going to find the negative reciprocal of that gradient and write that down. We're going to put that into the form y equals mx plus c. After you've done that, you're going to find the midpoint of the two original points and then substitute that into your equation to find out c. Then you're going to get that final answer. Good luck with your questions.